This video is about graphing quadratic equations that are in vertex form. Let's get started. This is vertex form. Y is equal to a, some leading coefficient, times the quantity x minus h squared plus k. And that is the vertex form because it tells you very clearly where the vertex is. H and k give us the numbers that make up the vertex. Now, the vertex of a parabola is that bottom of the valley point or top of the peak point of the parabola, which is very useful. Okay. Now, one rule of thumb that I tend to teach and tend to use is that when things are in parentheses, then we tend to be switching signs a lot, having to do with, at its core, the zero product property. Okay, so when things are in parentheses, we tend to switch signs, which happens also here in this equation. So this x coordinate, if you think of it as a -2, then you'll be switching the sign, and the vertex is a +2. Okay, so the sign is switching for the x coordinate because it is in a parenthesis. And the y coordinate, the k value, is out here. You don't switch the sign because it isn't in a parenthesis. Okay, now it's not mathematically y, but it's a good rule of thumb that works in a lot of equations. Okay, so keep in mind you switch the sign for x because it's in a parenthesis. You don't for y because it's not. So reading off the vertex to -4, that is either the bottom of the valley or top of the peak point, the vertex point for the parabola. Okay, now we can actually use some of our tools about end behavior to talk about the a value. Okay, if the a value is positive, then it's a positive even function, and this one is going to be going up because our a value is positive. If the a value is negative, then it's going down using our rules of end behavior that we learned previously. Okay. The other thing is important to know about a parabola is that it is symmetric. It's symmetric going through that vertex point. Okay. And so if we write the equation of x equals whatever this x coordinate of the vertex is, it'll be symmetric left and right according to that line of symmetry. Okay, and that's very useful for us. We'll kind of capitalize on that as we're plotting some points around the vertex. So here we've plotted our vertex at the point 2, -4. Okay, so next our goal is to plot some points. Okay, and so I'm going to plug in some points that are close to the vertex, and numbers that are close to 0 are also tend to be easier numbers to work with. So in this case, we've plugged in x equals 1 into my function. Okay, and 1 minus 2 is -1. -1 squared is 1. So I get 3 times 1 minus 4, and 3 times 1 is 3, minus 4 is -1. Okay, so a point from plugging in 1, I get the point 1, -1, which is right here. Okay, the other point that's easy to plug in that's close to the vertex is x equals 0. So I plug that in, and 0 minus 2 is -2. -2 squared is +4 because a negative times a negative is a positive. And I get 3 times 4 minus 4 is, let's see here, 3 times 4 is 12, minus 4 is 8. So I get the point 0, 8 from that. 0, 8 is right here. Now, I said before that it's symmetric according to this axis of symmetry that goes, as an x equals, goes through the vertex. So I'm going to use some symmetry for this point right here, and it's one space away from the axis of symmetry. So I go on the other side one space, and this point right here also must be on my parabola because it's symmetric. And over here I have, this is a space of 2 right here. So I go on the other side 2, and this point right here must also be my parabola because it's symmetric. And then I can connect the dots with a curve and I have that kind of a curve. Okay, and that's a sketch. I think the vertex and 2 points on left or right, and then you double that, you get 5 points. That's a pretty good estimation for that curve would be. You'd put in more points, obviously, and get a more specific curve of what that's going to look like. Okay, but that is how you graph a parabola, a quadratic, in vertex form. It gives you the vertex, you plot a few points on left or right, then you mirror it, and then you have a good sketch for what the parabola is going to be. So let's look at a few more examples of this. Let's look at number 1. If it's not already in vertex form, then complete the square, which we learned about in our last video about how to do that process, and then we're going to graph. Okay. So in this first one, I have no leading coefficient, so it's a little bit easier. And I'll rewrite this. Y is equal to x squared minus 2x. Again, I'll leave a space minus 2, so I'll fill that in later. Okay. If this was going to be a perfect square trinomial, then which one would it be? It would be x, and then what's half of negative 2? Half of negative 2 is minus 1 squared. That's if it was going to be a perfect square, it'd be that one because of the patterns we saw in our previous video. Which also means that this term right here is negative 1 squared, and negative 1 times negative 1 is a positive 1. Okay? But to keep it balanced and equal, I have to subtract a 1. Okay, to keep it equal and balanced. Now that plus 1 is really a plus 1 because I use no parentheses in this problem, as we'll see kind of in the next problem. Okay, and then negative 2 minus 1 is negative 3. Okay, so now that I've completed the square, I can read off what the vertex form of this graph is going to be. I can read off again, I change the sign for x, and I get positive 1. And I don't change the sign for y, it's not in a parenthesis, so I get negative 3. The vertex is the point 1, negative 3, which is right here. Okay, that's the vertex. And keep in mind that I have right here an axis of symmetry. Okay, so next I'm going to plug in some points around this vertex, and I also think that the number 0 is very useful for us. I'm going to plug in x equals 0. Now you can plug it into either equation. Generally, this vertex form one is the easiest to work with. To be honest, with 0, actually the original equation is easier, but as a rule of thumb, let's just always get in the habit of plugging it into this vertex form equation. So if x is 0, I get y is equal to 0 minus 1 squared minus 3. And negative 0 minus 1 is negative 1. Negative 1 squared is negative 1 times negative 1, which is positive 1. And I get positive 1 minus 3, which is negative 2. So I get the point 0, negative 2. And I graph that. 0, negative 2 is right here. Okay, but it's symmetric according to my axis of symmetry. So I get this point, which is on 1 point away from the axis on the other side. I get that one for free. Okay, next, let's plug in a different point. And I'm going to plug in the point, I'm just going to go to negative 1, because that's kind of nearby. So if x equals negative 1, then I get y is equal to negative 1 minus 1 squared minus 3. And negative 1 minus 1 is negative 2. Negative 2 squared is negative 2 times negative 2, which is a positive 4 minus 3. And 4 minus 3 is 1. So I get the point negative 1 comma 1. Negative 1 comma 1 is right here. Okay, and also it's 2 away from the axis of symmetry. So I go on the other side 2 and I get this point right here. Okay, and there's 5 points to give me a good idea of where this parabola is going to be. So I kind of sketch that out and draw a curve. Okay, and that's graphing a parabola in vertex form. All right, in number 2, let me show you how to do this one. This one has a number here out in front, so it's a little bit different. As I explained, the completing the square process is a little different as I explained in my previous video about how to complete the square. But that is where you will factor out this term, whatever it may be, out of the first 2 terms. So I'll factor 2 out, and I'm left with x squared, and then 2 times what is negative 8x, it's minus 4x. I'm going to leave a space like before, and then plus 10 is out here. Okay, so the next thing I do is I think about, well, if this was a perfect square trinomial, then what would it be? Well, it's x, and then half of negative 4 is negative 2 squared. That's the perfect square trinomial that it would have to be to give me an x squared minus 4x. Okay, but the number here would have to be negative 2 squared, which is negative 2 times negative 2, which is a positive 4. But that plus 4 isn't really a plus 4. It is 4 times 2, which is 8. So I just added 8 to this equation. So to keep it balanced, to keep it equal, I must subtract 8 from this side as well. Okay, so then simplifying this, 10 minus 8 is plus 2. And now I have the equation in vertex form. Okay, I know it's really condensed, and that process is a little complicated in there to complete the square, but it gets us into the vertex form pretty quickly. Okay, so again, the vertex is where you change the sign for x, so I get a positive 2, and then you don't change it for y, it's not in a parenthesis, so you get the point 2, 2 is the vertex of this parabola. Okay, and then keep in mind that I have an axis of symmetry right here going vertically through that vertex. Okay, now I'll plug in some points, and I think the points x equals 1 and x equals 0 are probably easiest to work with because they're small numbers and they're close to the vertex. If x equals 1, then I get y is equal to 2 times 1 minus 2 squared plus 2. 1 minus 2, starting in the parentheses, 1 minus 2 is negative 1. Negative 1 squared is positive 1. So I get 2 times positive 1 plus 2. 2 times positive 1 is 2, plus 2 is 4. So I get the point 1, 4. I can graph 1, 4 is right here. Okay, but because it's symmetric, I get one on the other side as well, one space away from the line of symmetry. Okay. Now, I will also plug in the point x equals 0. And let's see here, y is equal to 2 times 0 minus 2 squared plus 2. 0 minus 2 is negative 2. Negative 2 squared is positive 4. So we get 2 times positive 4 plus 2. 2 times 4 is 8, plus 2 is 10. So I get the point of 0, comma 10. And that point is right here. Okay, but it's symmetric, so I get it's 2 spaces away, so I go on the other side 2, and I get this point right here. Okay, and I get, as my parabola, I get this curve right here, and that's a graph for the parabola. This video is about graphing quadratic equations in vertex form. Thank you so much for watching.